My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 167. In this lecture, we will try to understand one simple example on Anova. I am going to explain the concept of analysis of variance with the help of an example. The example is that there are three methodologies. One way of teaching with the help of Blackboard, another way is case presentation, third way is PowerPoint presentation. Suppose I want to know which teaching methodology is more effective. Is there any influence of teaching methodology on student performance? So totally 9 students was taken. In each group 3 students are allotted randomly. Just see this table. How many marks are there? There are 9 marks corresponding to 9 students. So what you see here is the marks obtained by students. Whatever the values you are seeing, these are marks. What is the null hypothesis here? Just see, my null hypothesis is H0. My H0 is, I can say like this, mu1 equal to mu2 equal to mu3. What is my alternative hypothesis? H1 mu1 not equal to mu2 not equal to mu3. If you see, even this technique in Anova, analysis of variance, if I can say like this, if you see, even this technique name is Anova, analysis of variance, but I am comparing mean. What I am going to do here with the help of concept called variance, I am going to compare the mean of 3 populations. I am not comparing the variance. I am comparing mean of 3 populations. So for the group 1, I have taken sample mean. What is group 1? This is my group 1. Just see, this is, just consider, this is my group 1. How can I calculate mean? 4 plus 3 plus 2 by 3, that is 3. My x1 bar is equal to 3. In similar manner, what is mean of second group? That is x2 bar, 2 plus 4 plus 6 by 3, that is x2 bar. I can say x2 bar equal to 4. For group 3, what are the elements? 2, 1, 3, 2 plus 1 plus 3 by 3, that is my x3 bar is equal to 2. Then find overall sample mean. How can I find overall sample mean? Just add all the elements present in these 3 groups, and totally how many elements are there? There are 9 elements. That is x bar. That is overall sample mean. I am going to find out overall variance. That I am going to call it as SST. SST means what? Total sum of, I can say total sum of squares. Total sum of squares, isn't it? Why am I saying it as variance? Just try to recall our previous lectures. Let me go back, otherwise just let me write here. Variance formula. What is my variance formula? Variance formula is S square equal to sigma of x minus x bar whole square by n minus 1. The numerator, what is the numerator here? Sigma x minus x bar whole square. This is numerator. That I am going to take sum of squares, isn't it? So I am going to find out overall variance. That overall variance is SST, total sum of squares. I am going to group into 2 categories. First one is variance due to treatment. Variance due to treatment, I can say, due to treatment. That's first one. What about next one? Variance due to error. Variance due to error. Now I can say SST equal to total sum of squares equal to SSB plus SSE. What is this B? Sometimes we write B, isn't it? Between columns. B means I can say between columns. That is, I can say, due to treatment. This is some SSE. As I told you, what is my SSE? SSE variance due to error. Sum of squares due to error, I can say. SST is combination of this. SSB can be treated as treatment, SS treatment, I can say. Anyway, we will try to understand all these concepts with the help of simple example. First, we will find out overall variance. What is SST? I can say SST is, what is the formula for SST? Just let me calculate SST first. How can I calculate SST? It's simple and straightforward. Just see, what is the element? 4 minus 3 whole square. That's what it says. Sigma x minus x bar whole square. This is x. What is x bar? 3. Again 3 minus 3 whole square. 2 minus 3 whole square. 2 minus 3 whole square. 4 minus 3 whole square. 6 minus 3 whole square. 2 minus 3 whole square. 1 minus 3 whole square. 3 minus. Just I am subtracting this overall mean from each element of these groups, and after subtracting I'm considering sum of squares. Therefore, what is my SST? How each element is away from overall mean, isn't it? That's what I'm calculating. Overall mean is 3. After calculating, what is my value? SST value is 18. 18 is nothing but total sum of squares. This 18. I am going to see how much variance due to this teaching methodology. In simple manner, I am going to calculate SSB. I already discussed what is SSB, isn't it? SS, otherwise I can say SS treatment, sum of squares treatment. Otherwise, even what is our B? Between columns. That I already discussed. Just we will try to understand how one can calculate SSB. Just see, first one, this 3, this 3, this 3. What number of elements in each group? In first group, how many elements are there? There are 3 elements. That's why I'm writing 3. In second group, how many elements are there? 3 elements. That's why I'm writing these 3. In third group, how many elements are there? 3 elements. That's why I'm writing these 3. Isn't it? Next, what I have to do? Just see next. What about next value? What is this 3? What is this 4? What is this 2? Just see, 3, 4, 2. These are sample means. I can say this is x1 bar, this is x2 bar, this is x3 bar. This is my x1 bar, this is my x2 bar, this is my x3 bar. Isn't it? What about that, this number? 3, 3, 3. This is x bar. Overall mean, this I am subtracting 3. Therefore, my SSB value is essentially 6. Now, let me calculate SSE. How can I calculate SSE? Means error sum of squares. SSE means what? Error sum of squares. That is inherent variance. For inherent variance, when you look at the column, the first element is 4, isn't it? What's happening? 4. The mean of the first column. What is the mean of the first column? 3. Means I can say 4 minus 3 whole square, 3 minus 3 whole square, and 2 minus 3 whole square. Isn't it? I just collect all elements of first group and subtract its corresponding sample mean from each element and take square. Isn't it? In similar manner, just let me consider another one. 2, 4, 6. 2 minus 4 whole square. Just see, 2 minus 4 whole square. 4 minus 4 whole square. 6 minus 4 whole square. Isn't it? In similar manner, I can calculate for this one also. What's the mean corresponding to this one? 2 minus 2 whole square, 1 minus 2 whole square, isn't it? 3 minus 2 whole square. Therefore, what is total value? You are getting 12, isn't it? Now what I have to do? Now I have got values of SST, SSB, SSE. So now what I have to calculate? Now let me calculate degrees of freedom. How can I calculate degrees of freedom? For SST, what is the degrees of freedom for SST? Let me write here. How many possible values for SST? For SST, degrees of freedom is equal to, there are, for SST, what is the degrees of freedom? There are 9 elements, 9 minus 1, that is 8 degrees of freedom for SST. For SSB, what is the degrees of freedom? There are 3 columns. There are 3 columns. How many columns? There are 3 columns. 3 columns. Therefore, how can I calculate degrees of freedom for SSB? 3 minus 1. That is 2 is degrees of freedom for SSB. For SSE, for first column, let me say something about SSE. For first column, there are 3 elements. Therefore, 3 minus 1 equal to 2. For second column, there are 3 elements. 3 minus 1, 2. For third column, there are 3 elements. 3 minus 1, 2. Therefore, 2 plus 2 plus 2, that is 6 degrees of freedom. Therefore, SSE has got 6 degrees of freedom. Now we calculated degrees of freedom. After that, we have to find my F value. What is F? F is nothing but, I can say my F equal to, let me say like this, MSB by MSE. What is my MSB? MSB means mean square between columns. MSE means mean error square. MSE means what? Mean error square. MSB means mean square between columns. What is the formula for MSB? SSB by degrees of freedom, and MSE is SSE by degrees of freedom. What is my SSB? My SSB value, we already calculated. SSB is 6. Therefore, 6. What is degrees of freedom for SSB? SSB degrees of freedom. What's the degrees of freedom? 2. 6 by 2. By SSE, what is my SSE value? It's 12. What is corresponding degrees of freedom for SSE? 6. 12 by 6. That is, how can I write? 6 by 2 means I can write it's 3. By 12 by 6 means 2. 3 by 2 means what? 1.5. This is my F value, isn't it? Just understand what is my F value? 1.5. Just see, this is my F value. F equal to 1.5. This is calculated value. Now, I must compare this calculated value with the tabulated value. Let me assume alpha equal to 0.05. Therefore, let me say this area is 0.05. I must find corresponding F value. My calculated value, F cal, let me say F cal means calculated value is 1.5. Now let me check F tab. Tab means tabulated value. What is degrees of freedom? What is numerator degrees of freedom? Numerator degrees of freedom, SSB by SSE. What is SSB degrees of freedom? That is 2. What is SSE degrees of freedom? 6. 2 comma 6. This is 2. This is 6. That is 5.14. Isn't it? What is tabulated value? My tabulated value is 5.14. Isn't it? This is 5.14. Now, what is my calculated value? Calculated value is somewhere 1.5. It's left side of 5.14. It is in acceptance region. It is in acceptance region. Isn't it? It is not in rejection region. Therefore, what does it mean? We must accept H0. That is null hypothesis. So, you have to accept H0. This is a simple intuition for how this concept of Anova is working. In next class, I will discuss with the help of Python code. We will try to understand the same concept by writing simple code. Just go through this lecture. It is simple and straightforward. If you have any difficulty, just keep a comment. Thank you very much.